debugging server operations shouldn't mean guessing what went wrong behind the scenes. You'll see how to instrument a FastMCP tool with step-by-step debug logs, giving clients real-time visibility into file processing, from permission checks to completion, without cluttering your core logic.
At MCP, tool. Async def process file, file path, SDR CTX, context, SDR. Process a file with detailed debug logging. Await CTX, debug F starting to process file, file path. Await CTX, debug, checking file permissions. Hash file processing logic. Await CTX, debug, file processing completed successfully. Return file processed.
This demonstrates the client-server logging pattern, where backend execution details are streamed to connected clients in real time. The approach treats logging as a bidirectional communication channel rather than just server-side diagnostics, enabling clients to receive structured progress updates, warnings, and errors during tool execution. What distinguishes this pattern is its dual-purpose nature. It serves both debugging needs and user-facing transparency without requiring separate implementation paths. The pattern works by embedding logging calls directly within business logic while maintaining clean separation of concerns. The context object acts as a logging proxy, asynchronously dispatching messages to clients without blocking the main execution flow. This creates a declarative logging system where messages are categorized by severity level and optionally enriched with structured metadata, all while keeping the core processing logic uncluttered by transport concerns. This approach solves the visibility gap between backend processing and client awareness. Developers gain real-time debugging insights during development, while production systems can surface progress updates or errors to end users or monitoring systems. The trade-off is minimal performance overhead from async logging calls, but the benefit, unified logging that serves both technical and user-facing needs, makes it particularly valuable for long-running operations, AI tooling, or any scenario where backend transparency matters. Let's break it down line by line.
At MCP, tool. Async def process file, file path, SDR CTX, context, SDR. Process a file with detailed debug logging.
This defines an AI callable tool using FastMCP's decorator pattern. The @MCP tool decorator exposes this function to AI models, while the type hints and docstring automatically generate the tool's schema. All FastMCP tools should accept a context parameter for logging and progress reporting.
Await CTX, debug F starting to process file, file path.
This logs the start of file processing using FastMCP's context-based debugging. The CTX debug method provides structured logging tied to the execution context, ensuring traceability across async operations. All FastMCP tools should use this pattern for consistent observability.
Await CTX, debug, checking file permissions.
This logs a debug message about the permission check phase. All FastMCP tools should use the context parameter for progress reporting, and this follows that pattern by keeping the AI informed about operation status. The await ensures it doesn't block the async workflow while logging.
Hash file processing logic. Await CTX, debug, file processing completed successfully.
This placeholder marks where the actual file processing would occur. The subsequent debug log confirms successful completion, maintaining the operation's audit trail for observability. This pattern, debug before, debug after, creates clear execution boundaries in async workflows, critical for troubleshooting distributed systems where operations may span multiple services.
Return file processed.
This returns a success message to the calling AI model. All FastMCP tools must return a string, as this becomes the AI-visible response after execution. The return value completes the tool's contract, signaling successful completion to both the AI and the MCP framework. Contextual logging pattern. FastMCP's context object transforms simple logging into a structured conversation with AI clients, where debug, info, warning, and error messages become part of the observable execution flow. Progress reporting requires integer values for both current progress and total, not percentages or floating point numbers. The logging level you choose determines whether the message informs the client or just the server's internal logs.
The log message that speaks to no one becomes the answer everyone was waiting for.